Hello, honors pre-calculus students. Today's learning target is to talk about arithmetic series. We had developed in class that the sum of an arithmetic series is a1 plus a sub n times n over 2. So that is the textbook formula. We also discussed in class a different formula. We developed it. The sum of the numbers was the sum of any pair. I'm going to put quotes in pairs, times the number of pairs. And just for clarity, what we mean by the sum of any pair is it doesn't have to be a1 and a1. It could be a2 plus a sub n minus 1, so it could be the second and second to last. Or you could have the third, a3, plus the third to last, which is n minus 2. So symbolically in green, this a sub n minus 1 means second to last, and then this is the third to last. So if we look at problem number 1, I want to find the sum of the first 79 terms. So the first thing I'm going to do is plug in 1 for n. Doing that, I'll get negative 1. Then I'm going to plug in a sub 79. Doing that calculation, I get 1091. So the sum of the first 79 terms is a1 plus an times n over 2. So that's going to be negative 1 plus 1091 times 79 over 2. Doing that math, you're going to get 43055. Problem number 2 is very similar, but this time you might need to find the explicit formula. So for problem number 2, I'm going to find the explicit formula. The common difference is equal to negative 20, and the term before the negative 10, meaning the a0, I'm going to write that down. So a0 is equal to negative 10, and the common difference is negative 20. So that is the explicit formula. So the sum, the first 89 numbers, is a1 plus a89 times 89 over 2. I need to find a sub 89. So a sub 89, doing the math here, you'll get negative 1770. So the sum of the first 89 terms will be negative 10 plus negative 1770 times 89 over 2. And doing the math there, you will get the sum to be negative 79210. If we look at problem number 3, the first thing we need to do is expand it. So if you plug in the value of 1 into the formula here that I just underlined in red, you'll get negative 14. If you plug in the value of 2 into the formula, you will get 6. If you plug in the value of 3, you will get 26. And the last number that you're going to plug in for I would be 56. And when you do that, you're going to get 1086. Once we expand this, we now could say the sum of the first 56 numbers is a1 plus a sub 56 times 56 over 2. Doing the math on this particular problem, we'll get 30,016. In problem number 4, we're asked to find how many terms there are. So the first thing I'm going to do is find the explicit formula. So the explicit formula for this particular problem is going to be equal to 10 minus 7n, since the common difference is negative 7, and the a0 term is 10. The sum of the first n numbers is a1 plus an times n over 2. If I were to use substitution, the first term is 3. A sub n is the blue formula we just calculated. And then that would be times n over 2. And we know and I'm going to highlight this in green, that the sum is negative 31632. So I'm going to set that equal, and I got to make sure I copy that correctly. Let me rewrite that. So negative 31,632 is going to be equal to 13 minus 7n times n over 2. I'm going to multiply both sides by 2. So negative 63264 is equal to 13 minus 7n times n. I'm going to distribute, so 13n minus 7n squared. And now this is a quadratic, so I'm going to set it equal to 0, so 7n squared minus 13n minus 63264 is equal to 0. Then I'm going to use the quadratic formula. So n, excuse me. So I'm going to write this here. So n is equal to the opposite of b. So 13 plus or minus the square root of b squared minus 4ac all over 2 times a. Solving for n, we'll get n is equal to 13 plus or minus 1331 over 14. There are two answers here. One answer is going to be 96 when you do the positive case, and the other answer is about negative 94.14. Remember, n's got to be a positive integer, so there it means there are 96 terms that you are adding up. If you look at problem number 5, this is similar to number 4. If you were able to plug in I to be 1, you will get 16. If you plug in I to be 2, you'll get 22. If you plug in I to be 3, you'll get 28. And then the last term you plug in is n, so that's 10 plus 6n, and that's equal to 8798. So you can see that this is very similar now to the previous problem. So you could say 16, that's a1, plus 10 plus 6n times n over 2 is 8798. And this is going to be a quadratic again. When you solve the quadratic, you will get 53, or n is equal to negative 55.33. That's extraneous, so that means there are 53 terms.